So, welcome back for this second seminar of this Thursday. It is really with pleasure that I introduce the next speaker. So, the next speaker is Bram Vanderborght. I hope I pronounced it decently. So, I'm very happy to introduce him because he's a very important and special person for the BrIAS, as he served with me last year as the program director on the team of robotics. And furthermore, Bram is also one of the most known and relevant roboticists we have for sure in Belgium, but I would say also in Europe, and is active in a number of very interesting fields, very often in close contact on trying to do something that is for the common good. So I'm very, very pleased to introduce him, and I leave him the stage.
So thank you. So my presentation will be about core robotic technologies for sustainable robotic startups, because it's about sustainability. So we see, of course, robots playing an important role to improve the digital transformation, so improving productivity, return on investments, and so on. So typically what companies desire. But on the other hand, you have also the sustainability transition we need to make. And sustainability we not only see on economical side, but also on societal side and on environmental aspect. And this is, of course, typically more what the society or the government enforces. Think about, for example, the EU Green Deal. And in Brubotics, in our research group, we want to combine the two, of course, in a robotic context. And so making both groundbreaking new novelties, but gradually improving it and increasing the TRL in order to support existing companies in robotics. But yeah, we don't have so many robotics companies in Belgium or Europe. So that's why we're also trying to make startup companies. And of course, the robot is an integration of very advanced technologies, core robotic technologies, and they provide capabilities. And it's about sensing, processing, and actuation. And on the other side, you have the robot applications. And because, for example, for a drone, the sensors were small enough, the battery density, energy density was good enough, the motor strong enough, the processing small enough and powerful enough, literally a drone could take off, and you see the enormous amount of applications of drones, for example. But of course, collaborating drones like here Brian did, and having manipulators on drones is still a challenge. But also reinforcement learning, how to see, but also touch and so on, and the work of Kelly on improving the speed of cobots, but also there you need new technologies. And so you see that there is capabilities and requirements, and still there is a research gap. And that is, of course, an opportunity to do research, but also to do exploitation. And you have the famous Gartner hype cycle. It starts with an innovation trigger, a new technology, and then you go to a peak of inflated expectations, and then there is a delusion, it doesn't work, and then gradually it goes to the slope of enlightenment and the plateau of productivity. And so Gartner placed robots on the top here, on inflated expectations. I think it's not completely the case, because in the plateau of productivity you have already quite some advanced robots milking cows, surgical systems, like I said before, also in the industry. And for example, my vacuum cleaning robot became much more smarter. Even now with all the toys and the rubbish of the children of ourselves, it still be able to navigate and return and clean and so on, with a quite cheap device. And then on the slope of enlightenment, I think this is niche robots that can do only one thing. And then you have robots that I think go more to unstructured environments, like drones for transport of things, education robots, exoskeletons for rehabilitation, also warehouse robots, which gradually start to be implemented more and more. And in the disillusion valley, there I think also the autonomous vehicles are placed. When you see the predictions 10, 15 years ago, we would all drive with self-driving cars. Of course, there are huge advancements there, but I couldn't yet sleep in my car, of course. But also exoskeletons, cobots, quadrupeds, I think we still need to see the true value of them in our economy and society. And now more and more you have the humanoid robots. There are incredible investments in them. Hundreds thousands of millions are now pouring in it because they see it after text, speech, images, videos. It's probably physical AI. And so that's really where a lot of investments are made. But I think it's really on the peak of inflated expectations. So what are the core technologies in such a humanoid? So here you see, of course, end-to-end software which needs to run on chips. So yeah, what are there? The foundation models, the chiplets, because I think that we need new processing to make low latency, low power processing. For sensors and chips, 3D touch, I will speak about a bit of Melexis, situational awareness, those communication, like the previous speaker, but also servo motors, a big part of the value of it, the battery system, the body materials, and precision reducers, inertial measurements, and so on. But of course, in order to produce that, you need very large multidisciplinary teams in order to develop that. And so that's why we developed at the VUB Brubotics, which is a combination of different labs, like the AI lab, but also the electronics and informatics, and our robotics research group. But because Emmanuel already explained that the combination with the human, that's why we also introduced the human, social, and medical sciences in it. And this umbrella of different research groups, where we've said before mostly worked on human-centered robots, but now we expanded to sustainable robotics, are closely working together in different teams. Moreover, we're also affiliated with Vlaanders Make, which is an institute for helping the Flemish manufacturing industry. I was part of Vlaanders Make till a while ago. Now it's a colleague of our lab, Ilias, and I joined IMEC. Why? Because, of course, they're the chip research lab of the world, and I see a lot of opportunities that those developments also will end up in robots and have markets there. That's why also the focus on core robotic technologies. And so I mentioned that we are going to startups, and one of the startups that already exists for a few years was even founded with someone from the AI lab, makes bionic prosthesis, and there we started with the focus how we can improve actuation technologies, because typically motors for robots are very rigid, very stiff, and how we can go beyond it and include also the flexibility of the human body to store and release energy in springs, and how we can bring that for example, bionic prosthesis. And so this is the company Axillus Bionics, who has the IP on the ankle, on the bionic foot. Others in the lab are also working on the knee prosthesis, and here, for example, we participate in Cybathlon, which is an kind of Olympic Games for persons with a disability, but helped with technology. And now we're also trying to transfer the IP of the knee towards Axillus Bionics. And so also here it's a development of hardware innovations, control of it, model-based control, but a lot we cannot model, and therefore also AI is, of course, important. Instead of replacing human limbs, we also try to augment human limbs, and that are the so-called also wearable robots, in this case exoskeletons, which are categorized in two main families. So on one side, you have the very passive devices. So it are basically springs that store energy to pick up something, and that energy is released back again in the human body to support it. But of course, if you want to do other motions, they often hinder that motion. So they're not very versatile. And on the other hand, you have the powered exoskeletons, where you have batteries and motors and controllers, which of course add weight to the human body. But of course, they're also not very bulky and not very effective. And that's why, similar as the prosthesis, we try to combine passive behavior, storing energy in springs, and active motors where they're needed to make much more lightweight but also versatile devices. And here you see, for example, such exoskeletons for the upper arms. You have to paint the ceiling of your room, how painful it is. But a lot of workers have to work, for example, under cars and so on, but also to lift heavier objects. And also here we want to try to make a spin-off company out of it, which is called Husk. But it's hardware, and hardware is hard. It's, of course, much longer time to market than software. But on the other hand, there is IP involved, which of course has also value. And that is, of course, challenging. Hey, we need quite some investment money to bring this to the market. So hopefully in a few years we can realize this. Of course, in order to test our devices, we need labs to do that. And that's and what also understand what is the impact on the human body with human physiologists, but also even what's the social acceptance of those exoskeletons, and that's also the reason why we work together with the sociologists of it. And so we have about a €1 million lab supported by Flanders Make with motion capture systems like a Viking, but also wearables, insoles, force plates, and so on. So we can investigate objectively what is the impact of different exoskeletons, but also cobots, as you see here, on the human body. So in the drivetrain, we investigated a lot locking mechanisms, springs, and so on, but also the gearbox is an important component, and Pablo is in the room who leads this venturing effort in order to make exoskeleton. But let's hear to the video.
And this is the pinnacle of what robotics engineers can build today. What's the problem? Today's robots require big and heavy gearboxes and motors to move around. This is known as the hardware problem of modern robotics. How can we make motors smaller? One way is to put more teeth in the gearbox to increase its gear ratio. However, this makes the gearbox clunkier. On the flip side, if we try to shrink the gearbox instead, we just end up with a huge and heavy motor again. At ILOS, we've re-engineered a gearbox with a uniquely efficient planetary movement. Thanks to its novel topology, our gearbox produces higher gear ratios without any need for extra teeth or extra bulk. Our patented technology also minimizes relative movements inside the gearbox, making it more efficient and even lighter. The ILOS gearbox cuts the weight of the motor gearbox duo by 30%, ultimately making the robot up to 50% lighter. The result is an effective and easy-to-control robot that's eco-friendly and truly beneficial. ILOS, shifting robotics into higher gear.
So apart from actuation, we also need to improve sensing. And because for our exoskeletons, we need to know the intention to move. Because if I want to lift to stable, which is far too heavy, measuring only the positions, it will not be able to move. And so that's why I need to go to the origin of that motion, which is my brain activity, but that's very difficult to measure. And then, of course, it's looking how the muscles behave. And that's why we have here a sense-wise interface with EMG, but it is a very noisy data that comes early, and that we combine with pressure sensing, which is cleaner, but comes a bit later. And like that, we can, like here, detect the intention to move, because if we want to go to a rehabilitation device, like here, with a cobot, just moving the arm around, the patient will not rehabilitate. So we need to see what is the intention of the user to move, and then we can assist with the precise impedance control, extra energy in the system in order to move. So this was a finalist for the KOKA Innovation Award, and we wanted to create a company out of it. But first of all, the medical robot is still very expensive. The reimbursement of physiotherapists is challenging in Belgium. And it's a long time to market because it's a medical device. It needs all the certification, and investors are not so willing to take that risk. And that's why the company pivoted to sports injury detection. So that's why it's kind of sensorized sports garments. So from the field, we can track not only the motions, but also the muscle activities. And the idea is to go to elite sporters because they have a medical team around them, which can also help interpret the data so that we can gradually also go to recreational sporters, which of course don't have a medical team around it. And so this company has been founded since a few months. Then also we work together with Melexis. It's a Belgian company that makes very interesting sensors for a lot of cars around us. But of course they also see those new markets of robots. And robots need to go in physical interaction with the environment. And a lot of AI is on vision. But our biggest organ is our skin. And our skin is super important to interact with the physical world. And so in the sensorized interface, they were at only pressure sensors, so not able to measure the shear forces. And so here you have a magnet on top of a chip in an elastomer, and if you put pressure in the 3 directions, this magnet will slightly move, which can be detected, and we can derive the forces in the 3 axes to it. So that's why you see with very small force, even with a paper, we can move this exoskeleton around. And that allows us to measure forces which are even like torques, which with traditional pressure sensors you will not be able to measure. And we also want, when I want to hold fragile objects, for example this one, I want just enough pressure that it doesn't slide down, but also that I don't press it together, like for example with fruits that would create damage. And here you see that we're pressing on a building, on a block, and you see the forces being changed. And so there we also are experimenting with reinforcement learning to see how much pressure we exactly need to lift up objects. And I think such information is fundamental also for foundation models, and that we not only train on vision, but also on touch interactions. So when I see something and I grasp it, that I can react to this. So we were part of a European project to improve ergonomics of workers with exoskeletons and cobots. And one of the implementations we did was with Volkswagen, where there is this 14 kilo compressor component. Imagine a worker the whole day taking 14 kilograms, so very bad for their back. And so also in industry you have the case that all products have small variations, and that's why we also have a screen on top of it that informs the worker which operations, which task he or she has to do. So it was a nice, successful demonstration, but it didn't end up in the production chain. Why you see here in the beginning, the robot moves extremely slow. So it cannot reach the takt time in the production facility. So 2/3 of the robot developments, they fail due to speed. Of course, you can say, okay, let's move much faster, but it's dangerous because a human can be there. And that's why we're also making a new venturing effort with Konstantin leading it, where we have a multimodal perception pod at the end effector, creating an occupancy map around it, where we want to go close by to cube centimeter resolution. We also combine different sensor modalities that even in different environmental conditions like fog, rain, and so on, we can see through it. And then we also have a digital twin, and you see when there is nobody around, the robot can move at full speed. It's not yet certified, so we were not allowed to go full speed at this fair. But you see when someone comes closer, the robot slows down and then finally stops. And so latency, like Jan mentioned, is super important, and that's why we're also now working together. Like, of course, this is one agent having a perceptor ring, and we cannot share our eyes there, but robots with a communication system can potentially do that. So how we can combine the occupancy maps of different agents, and then, of course, bandwidth, latency are super important. So that's what we're trying to do together under this BrIAS part. And then, of course, when robots need to work together, we also need to know where it is, and that was also the motivation for my last question to Jan. Indoor you don't have GPS position, so how you can know where the robot is? And then you can use SLAM as synchronized localization and mapping. But in many environments, the number of features is not enough to have a reliable position. And that's why we're working in this case with ultra-wideband localization. So where the agent only with an ultra-wide anchor on the robot and on the place where it has to go, it knows where to go, and then it uses its slider to do obstacle avoidance and so on. And so that's why maybe in the future we can combine communication with this technology in order to know where is the relative pose of the different agents in the environment. Another aspect is battery management. During Corona, my laptop died because it was always fully charged. So now I have a program on my computer that limits the maximum charging rate, because anyway I don't need it. Maybe when I go to the United States, I want to work on the plane the 8 hours, and then I need the fully charged batteries. On the other hand, on the rest, yeah, the battery just degrades when you fully charge it. And that's why we're also working on a spin-off company, hopefully, that can monitor, because the system knows which are the different paths that the robot needs to take, how we can optimize the charging so that there is a longer lifetime of the batteries. Another aspect is the materials of the robot. Our robots are very complex, and when broken, it's very lengthy repairs, or you throw it away, which adds to the increasing e-pile. And so we use also more and more soft materials. If, for example, this is a very simple gripper, which is a balloon, and you make it stiff by creating vacuum, and then you can pick up objects. But same like the human body, we are not over-dimensioned, we have not very strong materials, but when we are injured, we can often repair our wounds and fractures, and we thought maybe we can also bring that in materials development, and that's why we started working together with the materials, the polymer department of the VUB, to create self-healing materials. So here we exaggerated with a cactus that will of course damage our material, and then you have leaks, so it doesn't work anymore. And then we can apply heat so that you see that the network starts to repair, and the mechanical properties of the material after damage are exactly the same as before damage, which means you can go back to using the system. And so we need to innovate the complete value chain. So we have a portfolio of materials which can be stiff and rigid. We can mold it and print it, which is exceptional because it's a network polymer. Like a tire, you cannot print again, or you cannot even recycle it, because that network is fixed. We can, with the conductive self-healing materials, also embed sensors in it and also have a heating network in it. But we also innovated materials so that they can heal at room temperature. So here we cut the material, and a few seconds later it's healed enough to go back into action. But of course we don't have control of in which environment it's healed. So if it's dirty, then you have the problem that in the scar there is the particles, and that's why we also developed heating elements in the soft robot that you can, for example, clean it, you send a current through it, it's up, and it can heal. Moreover, we also made multi-material parts, because if you look to our human hands, we have stiff materials, like rigid materials, like nails and bones, but also more elastic, and they're perfectly combined. But if we combine different materials, we need to screw them together or glue them together, and often there are the stresses. Where are the failures? But we heal them together, so the interface is perfect. And so we have 7 patents on it, and also recently we created a spin-off company, Valence Technologies, as a platform technology, which is sustainable materials, because when damaged it can heal. Moreover, you can chemically and mechanically recycle it. We're using biosources, and we're studying biodegradation. Moreover, we also made a new innovation that we have self-closing suction cups. So when not all suction cups are in contact with an object, you cannot create enough vacuum and you cannot pick it up. But our suction cups, due to the design, closes itself, and so you can pick up a more wide variety of objects. So how you create technology that goes from very low TRL level to valorization. Yeah, for that you have the technology readiness level. 0 or 1 is an ID, and that's where we have our very fundamental projects like ERC grants, or also for the self-healing we had a FET Open, which is now called EC Pathfinder, which is blue sky research. But then you end up with TRL 3, nice lab demonstrators, nice papers, but then the valley of death happens, because for an investor it's still too risky, and for the research part, yeah, the most of the innovations are done. And then we were very lucky to have an AC transition, where the ideas do on one side do the business aspects, and on the other hand, maturing the technology. And so that's how we can overcome this valley of death towards a spin-off creation. So now we're applying for an AC accelerator grant for the spin-off. And of course, it's a platform technology, so you can go to much more markets. And so that's why we're developing parallel projects to go to new markets. For example, we're studying self-healing medical phantoms to do surgical training. And how we do an IP management, yeah, it's also, I think, a challenging thing. So, of course, for spin-offs, often they need patents, because that's, of course, something of value for the investors. Some things you also need to keep secret, because, yeah, all the processing parameters are, yeah, difficult to patent, but throwing them on the street is also not so interesting. But on the other hand, those technologies need to be used in applications which are beyond the capabilities of our lab. So that's why we also make tutorials, open source control, where we, for example, had a tutorial paper, how to use our materials, so that it can go beyond applications, beyond our capabilities. I think it's also very important to do VOCs, voice of the customers. In the beginning, we develop our technology, and then we think, maybe it's nice to make a spin-off company. But the needs of we as researchers want to add more and more complexity and cool things, but that's not what the market needs. Because they need cheap products, robust products, and so on. And so instead of doing the VOCs at the very end, when basically your money is burned, your research money, we try now to do it much earlier in the process. So, for example, SafeBot, the researcher, he started with doing a lot of voice of customers with a lot of companies to understand their problems with their needs in order to develop a product target on those needs. I think it's also important to don't try to conquer at once the world. What you see now, the markets for humanoids are billions of euros. And you think, wow, I will enter it. But of course, they are the big sharks. And so I think it's better to go to a beachhead market. The idea comes from the World War II. First, you land on a quite safe beach with not a lot of competitors, and then you gradually take different parts of the market. Now we are developing all those different startups. We thought, yeah, why not combine them in a kind of accelerator hub? Because if you see other countries, they have much more startups. Of course, you can say Denmark, Germany, United Kingdom, that are much bigger countries. Of course, they have more robotics companies. But if you see Denmark, Switzerland, the Netherlands, and we compare the number of robot companies divided by million of inhabitants, we see Belgium is behind. And that's why if you have an ecosystem, yeah, you create that, yeah, innovations can accelerate. You share talent. Maybe one company goes bankrupt, but that person has a lot of talent, so can you not reuse it or has a different role in the company? Also even reinvest money. And that is what we exactly want to do in the robotic startup in Zellik, where VUB has a research park, where there is also the new VUB supercomputer hosted. It's a park on sustainability, and so we want to offer different activities to the companies, both office space, but also supporting them in research, but also infrastructure, because again, robots is a hardware-intensive component, and will all the companies have CNC machines and 3D printers, which is a lot of capital that you need to invest in it. Why not just share those facilities? Also, coaching, networking, upscaling, funding, and so that's why we're now collecting a lot of companies to offer services to them, so that we can make those robotics companies as successful as needed. So thank you. So that was Brubotics, how we go from core robotic technologies, from very basic innovations, to gradually increase the TRL to come to support existing companies, but also create our startups. Thank you. Are there questions? Their mics being...
Oh, okay, so are there questions? So if not, I have one that is, of course, the creation of a startup or a spin-off. It's something that involves multiple actors. One actor is the researcher that takes the risk,
which is super important.
One other aspect is the laboratory, but also there are a series of other actors, like the university itself, that is at the end the owner of everything that is IP and so on, possible investors and so forth. What do you think that is crucial in terms of policy to foster the creation of spin-offs?
Yes, so for a company, indeed, all the IP developed is owned by the university, but of course the spin-offs need those IP, and then you need an agreement between those two parties. And yet the entrepreneurial team in it is super important, because they need to turn from a researcher or an excellent researcher into an excellent entrepreneur, which is different capabilities needed. So it's a whole learning process. And then, of course, they need to go in negotiation with the university. And there we see that, there is still some friction currently. And that's why we think that maybe a kind of framework is best in place. And that, for example, in the Netherlands, the different universities with the different stakeholders agreed on such kind of framework guidelines about IP rights, royalties, shares, and so on. And I think this is a bit missing in the Flemish landscape, and I hope that can be realized, because, of course, as an entrepreneur researcher, you're between the investors that say, don't pay for it, maybe even do it alone, and the university that, of course, also invested in it in the patents, and also the research group, where you need to have a fair deal, I think, because on the one hand, you need to make that a spin-off company is viable. If you take too much money, it will die. So it's not in the interest of the university, because then your patents are worth nothing, or you need to resell it, which is even sometimes very challenging. And so having, of course, a fair thing. And so I think this needs to be improved. I think, on the other hand, because now we have several startup initiatives, it inspires also our researchers, and that's why I think it's also very important that they kind of unite to share experience, best practices, stupid mistakes they did, because you can also learn a lot from that, and it's often now all the successes, but you don't see all the failures behind it. And so that's why it's very important, I think, to create such a hub of robotics companies, where we also want to attract from other countries or from Belgium companies to it, to really work together with the specific needs of hardware robotics companies.
Thank you. There's a question there.
Yeah, so I was wondering... Hello. I was wondering, so as a research group, you've created many successful startups. What are the most contributing factors to create such an ecosystem? Is it to make your young researchers enthusiastic from the beginning? Is it to make sure you understand the market very well and choose the right research topics? What would you say were the most important actions you took as a research group?
Yeah, of course, first of all, we don't have so many successful startups yet. They're in development. But I hope they're successful ideas at the moment. But I think it's, also as a research group, we had to learn a lot. I remember our first startup idea was a social robot, because we did also a lot on social robots, and we thought to make it open source, because we thought Arduino and open source printers, it works pretty well, but investors are not very keen on that, so that I think was the first realization. We really need the patents, and more than patents, also the IP. Then I think another aspect was doing much earlier what investors need or want, because they also do their homework, and do it as early as possible, because then you still have the funds. Of course, you also need, and nobody asked at a certain moment the iPhone or maybe the car if they had horses. The traditional thing, you want a faster horse. And so you also need to push there with your own vision. So that combination for innovation and persistence, because it took us also a while to transfer to investors the idea of, for example, the SafeVod concept. And so, I think then it's also a bit of part of luck to really find kind of a value chain of who wants to invest to buy your product. And I think it's very important to try quite early on to find your first potential customer who is willing to pay even a very small amount, because then he has to go in his or her money pocket to do it, because otherwise, cool idea, continue, and when it's there, I will wait. So I think that's also an important aspect, and and that's a bit what you create open and what you do protected, and to play a bit, to have a balance there, especially because it's not an end-user product sometimes, it's a component that needs to be implemented in a bigger system. And so, so I think our next step is, creating that robotics hub to really share experience and networking and, learn from each other, and also offer services between each other. And for example, our sensorized interfaces is maybe important for the exoskeletons, for example, and attract other companies that fit in the value chain.
Thank you, Bram, for the super interesting talk. Could you share with us your maybe experience or observation about the interest of the investor currently, the landscape of the funding from investor currently compared to maybe 5 or 6 years ago, so before and after COVID?
I think it's challenging because we don't have so much VCs, we don't have so much risk investors. If I see the difference with US and Asia, where even a while ago I saw companies that I thought, do they bring this to the market? I think there could be much better products, but on the other hand, they had a company, they had interactions with customers, they learned probably very quickly, and probably several died in the meantime, but on the other hand, several were successful. It's like in electric cars, Tesla laughed with build your dream, buy it. In the meantime, it's a very successful company, I think. And so I think it's a bit a problem, a challenge in Europe, that risk investors don't want to take so much risk. They want a very short time to market. They also want to see that you have different options, which I don't think is good. I think you need to go for one market, and if it's needed, pivot very fast. And so we don't have a lot of competition in it, so we cannot put different risk investors against each other to have the best deal of it. And so I think in Europe the research is very good. Europe invests quite a lot in it. So I find it very sad, where are the humanoid companies developed? I mean, Europe has very cool humanoid robots from DLR, Karlsruhe, IIT, and so on and so on. and where are the companies in the US and in Asia. So I think we really need to work together to make a robotics thing, because I think on a geopolitical level, yeah, that will be otherwise challenging.
There is a question there.
Yeah, it's a little bit continuing. Thanks a lot for the talk. It was really insightful and nice to hear. Continuing on this topic, you said that Europe really needs more investment in robotic startup, but isn't there a problem of just quantity, which is the capital is mainly in the US? And a lot of European companies do try to deal with that by opening an office in the US or opening a branch in the US. Is this something you're considering, or is it something that is part of your thinking, or is it something you would rather avoid?
Yeah, I think now the situation in the US is not so interesting anymore. Yeah, I even see a bit the opposite effect that, American companies are, I think, more and more interested in Europe. I think you also see it in the stock market, how it goes down, and in Europe it goes up. So it's maybe an advantage, although I find it pity for the US. But yeah, that we see also, so we didn't go abroad yet, so that's why I also see a role for the robotics hub to make connections with other robotics hub, like Pittsburgh and Silicon Valley, so we can exchange companies a bit to say, and also have a network of networks to say. But yeah, it's also very challenging, and yeah, we don't only need to look to US, but also I think to Asia and especially China, where also aspects on IP are not so trivial. Again, also there it's a challenging thing, and that's why I also think we need to combine this hardware and this AI software, because on the hardware you can take the IP. Hey, you see open AI and then DeepSeek and Whoops go down, because where is the IP there? But I think you need to enable the hardware with AI, and yeah, that combination I think needs to be will be important, and that's why I feel a bit with Europe that they now put a lot of effort and focus on generative AI things. I'm very afraid that they will forget that they're also very strong in Europe in hardware, and that they will lose these things, and that we will develop a lot where others will copy and use it. So I think, yeah, we need to keep that combination. And again, Europe is quite strong in manufacturing in hardware, but with the recent trends, I feel that we're losing that aspect, and that it's, I think will be a crucial mistake, I think.
Do you know what's the percentage of research making by the company themselves in R&D, and what's the most important in Europe? Are the company that they're doing their own research to provide some new tools, or the universities, and what's how they can mix, and what's the percentage of each part?
Yeah, that's for me hard to say. I think the role of universities is a low TRL, the basic innovations, and I think it also, underestimated the importance of open source software and AI, where a lot of companies run on and can make very fast software because a lot of code is openly available and they assemble it into systems. And for example, all the underlying technologies of your iPhone, if you see the talk of Mazzucato, I think she is an Italian economist, all the basic technologies from lithium-ion batteries, GPS, multi-touch screens and on are all funded by government-funded projects. So I think the importance of the government is the biggest risk investor at the moment. But of course, creating a company and making something so beautiful to say as an iPhone or a Samsung phone and so on, that's the role of the companies. And so, that interplay between government and companies are important, but that also means that those companies need to pay taxes, because we need to raise engineers, we need to raise our students, and also to pay for the innovations that then gradually go to industry, but it takes a very long time. It's very risky. I mean, all the developments I show, yeah, that is often 10 years of research in quite large teams. So yeah, and with a lot of a graveyard of research that also failed. And so the lower the TRL, the higher the risk, but then also the society and the government and the population has to accept that there are risks and then gradually to go to innovation. But how much companies do, it's challenging to say. Also to say that often it's complete secrecy. So Dyson has 700 engineers in robotics. Nobody knows what they're doing. We would probably have a guess. It's probably household robots. You see, there are also the vacuum cleaners, but I think they're preparing much bigger things.
Hello, Bram. Thank you. Did you ever consider a subject in the educational or entertainment field?
Maybe social robots falls under it, but not in fact yet. But for example, Disney has also quite a big research lab on robotics. And for example, I just heard that one of their cool social robots is entering the Disney, how you call it, Disneyland in Paris. So yeah, also robots are used for entertainment. But yeah, we didn't go into this, except more educational robots for children with autism and diabetes. But because of the declining interest of Europe in it, yeah, we had to abandon that.
So I will go for my privilege for a last one, because otherwise it will stay a lot. And it's more a general question that is about the role of university in all of this, because as you were saying, university has already a very complex task that is education on the one hand and research, but not innovation, in the sense research and low TRL innovation. So one thing that I was always thinking, and somehow you also gave an answer during your talk, is if university is the best place for the management of a launching of spin-off, or we would need more of some intermediate layer between the research and then the industry.
Yeah, so I think we really need to reinforce entrepreneurship at universities, but also understand it's a very challenging field. It's also a matter of continuous funding, and typically a project is 3 years, and then yeah, that's my daily work to write endless amount of projects in order to continue to fund it, and also not only, it's maybe one of the slides that should have shown, but for example, the research team on the self-healing was from both the material side as the robotics side is 20 people. Yeah, even one European project, cannot pay for that. So it's really a combination of a lot of grants on national level, FAO, and European grants, and so on. And also, when even a big project finishes, after 3 years, they're all on the street, and how you can maintain that, or at least the core of that team, in order to go to a spin-off. And that's an incredible big challenge, where often, also like the social robots, it just failed, and we couldn't go to the next step. Probably we were also not yet ready for that. But it's quite some effort to find the funds in order to continue those developments, to go to companies. And that's the thing. Does the government need to pay that, or do the risk investors have to pay that? I mean, that's a bit a balance that society has to take.
Also because anyway there is a gap. There are certain TRL for which there is not the effect, wow, you have just to keep tuning,
for example, on the self-healing materials, we had a science robotics paper, and it was super cool, and now it's fine-tuning the materials so it's all the quality standards for a long time, which is not so super cool anymore and hardly to publish, but it's critical. Also affordability, I think it's also a very quick question. For example, that I like of the Melexis sensors, it's not a sensor of a few €1,000, but how to design it so it's cheap, because you need many of them, and you don't want a humanoid of millions of euros, you want, or 100,000 of euros, you want it in a cheap car. So that means all the basic components need to be cheap and super reliable. And yeah, that's also a very important but challenging part, and that's also risky for investors.
So I think that there will be many other discussions going on, so I would like to thank again Bram.
Thank you.
And to thank him especially because he could have been probably much more in his comfort zone presenting us his latest result from the scientific viewpoint, while instead he brought something that touches many of us as academics and for which we are very sensitive and very often also very discouraged, I must say. So thank you, Bram, again, and thanks to all of you. I imagine that finish this formal part, we will have various discussions. There will still be a coffee. And thank you for being with us.
Thank you.